Hello students, today we will be discussing electric flux, area vector and Gauss's theorem from the chapter Electrostatics. In the last session we discussed about electric field lines. In this session we will be discussing about electric flux. Electric flux is number of field lines crossing a given area, and it is represented by the symbol phi, and it is equal to vector E dot vector delta S, which is equal to magnitude of E. E is electric field and delta S vector, that is an area vector. So magnitude of area vector is area into cos theta. Theta is the angle between vector E and vector delta S. So before proceeding further, we should know what is an area vector. Area vector is actually area into a unit vector that represents the direction of area vector. So if this is a surface whose area is, let's say, delta S, if S is the full, S is representing area and delta S is the small, this pink colored area, then area vector has a direction which is perpendicular outwards. It is an outward normal like this, and if the surface is like this, the area vector's direction will be this direction, vector outwards. So the direction of area vector is always a vector drawn outwards. So we can say if this is the surface of area delta S, then area vector delta S is equal to the area delta S into a unit vector in the direction normal outwards. So that's all about area vector. Now we should know what will happen to flux when the angle changes. Definitely, because E delta S cos theta is flux. So when theta is 0, we know cos 0 is 1, and the flux will be E delta S, which is maximum E and delta S, because cos 0 is 1. Now when theta is 90 degree, cos 90 is 0, so flux is minimum. That is, when E and delta S are parallel, the maximum field lines will pass through it, and when E and delta S are perpendicular, no field lines or a very few field lines will pass through the surface. Now to know the unit of flux. How can we find the unit of flux? Flux is E delta S cos theta. So unit of flux, unit of E is E is equal to F divided by Q. So unit of E is Newton per Coulomb. So Newton Coulomb raised to -1 into meter square will give the unit of flux. Now based on this electric flux, there is a theorem called Gauss's theorem. It's a very important theorem. According to Gauss's theorem, total electric flux through any closed surface in vacuum is 1 by epsilon 0 times the total charge within the surface. So flux is equal to total surface integral of E dot ds, that is total flux through any closed surface, is Q total, that is the total charge in the system in that surface, divided by epsilon 0 if it is vacuum. But if the region, if the space in which the charges are kept is having a dielectric constant K, then flux will be Q divided by epsilon, the electric permittivity of the medium, which is equal to Q divided by K epsilon 0. If instead of vacuum there is a medium of dielectric constant K, then flux is Q by K epsilon 0. If it is air or vacuum, flux is Q divided by epsilon 0. We will discuss the problems based on Gauss's law in the next session. Thank you for watching.